So, hello guys and welcome back. So, today the question that you see in front on the screen, this question is basically a question on combinatorics, and as you might have read my post, very few people were messaging me continuously. I received a lot of DMs that about combinatorics questions. So, this question is from EGMO. I will tell you the full form. This question is from the EGMO 2025, the European Girls Mathematics Olympiad. Okay, this is from 2025, and I guess this was paper 2 or set 2, whatever they call it. I don't know. So, this question is a really good question in the sense because this is not very long, but the observation that this question will give you is something that you actually need to know. Because, see, calculus is something that is JEE, like, so to our level, whatever amount of calculus we know, JEE can stick to the advanced level of that. Okay, I'm talking about syllabus. But when we come to combinatorics, as we go on to advanced problems, they tend to go out of our syllabus. Okay, there are huge lot of things. There is pigeonhole principle, and there is a lot of things that are not in our JEE syllabus. If you are preparing for Olympiads or something, then maybe that will be relevant. Okay. So guys, this is not on pigeonhole, but this question is something that you guys, I guess you need to know about. Okay. So guys, this question will take a lot of time to explain. So if you want, try this question out, or maybe you can take a screenshot of this and exit the video right away. Just try it out for a few days and then come back. That's my opinion, because this question is a really good question. Okay. So you can pause the video. I will wait for a few seconds and then start off with the solving. Okay, so guys, I hope now we can start off with the discussion. So first of all, like before solving this problem completely, main thing that we are here for is to understand this, okay, because this will take a lot of time to understand. So first we will read the problem. So in each cell of a 2025 cross 2025 board. So first thing is, this is a 2025 cross 2025 board. Okay. Now, if you don't know what 2025 cross 2025 means, you can consider that there are 2025 units on each side of this square board. Okay. Now, a non-negative real number, non-negative, so it is positive, is written in such a way that the sum of the numbers in each row is equal to 1. So, like I am reading the question and writing the data. Okay. That is important. So, each row, you can write each row sigma is equal to 1. And similarly, after that, you will see sum of the numbers in each column also is 1. So each column sigma is also equals to 1. Now we have to define Ri to be the largest value in row I, and let capital R is equal to R1, R2 up till R2025. So capital R is basically given as sigma I equals to 1 to 2025 small ri. And what is the small ri? Small ri is the largest value in row I, or rather the maximum value in row I. Okay. Please understand this very carefully because each element of this particular question is important. Similarly, we have Ci also. So Ci is the largest value in column I, right? And after that, we have the capital C, which is again the like similar sum of Ci. I equals to 1 to 2025 Ci. And now they have asked us what will be the largest possible value of R by C. We have to maximize R by C. Okay. So guys, in order to maximize R by C, we have to do something, right? So like this is an Olympiad level problem, so I am treating it like that. See, like these type of questions, this length won't ever come in your JEE Advanced. I can easily like guarantee you with that, unless your luck is very bad, because JEE Advanced has given such long questions in the past. Okay, they have, but normally these should not be given unless your paper is too tough. So I am going to solve it in the Olympiad pattern only. Like, don't go with the timings and all, go with the understanding, okay? The learning you get from here. Okay. So guys, first thing is like think a little bit. when row column sum individually, each row and each column sum will be 1. So what is the first instance that can come to your mind? The first instance when I think of this thing here, each row sum 1 and each columns sum 1, then the first instance that comes to my mind is one element in, like, let's consider this row, say this is R1. Okay, not R1. Let's say here this is C1 and this is R1. Okay, like let's take an example. So if this is R1 and this is a C1, then what my instinct tells me, the first thing that comes to my mind is I will just put a 1 here and make all the other elements, observe my pen, all the other elements in this row and this column 0. That's the first instance that we can think of, right? And when you go after that, like when you go to row number 2 and column number 2, you can't put a 1 again here because this is already preoccupied with 1 and there is only one allowed in this case. Why? Because all the elements have to sum up to 1 in each row and column. So for that case, you will actually put 1 here. And like you can see, this is the box. This will be your C2 and this will be your R2. And in a very similar fashion, here you will have 0. These elements will all be 0. These elements will all be 0. Okay. And this will go on continuing. Again, you would have maybe 1 here. Like this is not the answer. Okay. We are considering cases right now. We will arrive to what we know. And I guess this will continue till here. The last row and last column, rather the last corner element of rightmost corner element of this 2025 cross 2025 board. So this is actually your like 2025 rows and 2025 columns, I guess, right? So this thing is actually R2024 and this is C2024. Okay. Okay, wait. I'm sorry, not 2024. It was 2025, right? Yeah. 2025. Yeah, so this can be one case. But here R by C, if you calculate, it is coming to be equal to 1. Because largest value Ri in any row and any column, like Ri and Ci in any row, any column, it is 1. So R by C will come out to be 1 because their sums would be 2025 each. So when you divide them, quotient would be 1. So like, okay, but this is not what we are asking for. We need the largest possible value of R by C. So to make R by C largest, we kind of need these Ri to be largest, right? Ri and Ci, the individual elements, they have to sum up to be largest. So let's consider one more case. I will change the screen and then show it to you. Okay, so let's consider one more case to find out how we can maximize this. Okay, and guys, I am just taking a small notation here. Like write this down. Let the maximum value be called as a red cell. Okay, just a name, red cell. Now what is a red cell? Basically intersection, like those small square boxes I was drawing, this is what I am trying to call a cell. Okay, like the element, don't complicate that too much, it's just the element. I am calling it a red cell. Okay, irrespective of whether it is a like in a row or a column, wherever it is maximum, we will try to call it a red cell. Okay, so guys, now what I am doing is, let's leave off 1 and consider something next level. So one more thing that we can do is, after 1, if you look a small step ahead, what you will see is we can put 0.5 and 0.5. Okay, so why can we put this? Because basically if we put 0.5 and 0.5, this is your, I guess, C1 and this is R1, R2. So if this is C1 and this is R1, R2, you will see C1 plus R1. Okay. Okay. So this column 1 here, if you see, this column 1 is adding up to 1. Now you would ask me a basic question like, if this row 1, this row 2, they contain only 0.5s here, then what about these places? Okay, so just hear this. Basically, this is an important part. Okay, like listen carefully. Basically, 0.5 here is already present. We need total of 1 in each of the individual rows. So I am writing a 0.5 outside here and another 0.5 outside here. I hope you can see my pen. Oh wait, I will write this a bit clearly. Yeah, now this is, I guess, visible. So writing 0.5s outside here basically means that for the columns it is obviously satisfied, but for the rows, all these like 2025, 202 out of the 2025 places, first place has been filled, you can say, right? So empty 2024 places are still here. So out of those 2024 places, you will fill them with arbitrary values, like anything. Those 2024 places have to be filled with arbitrary values, not necessary they have to be equal. You can fill them with arbitrary values such that they sum up to 0.5. Okay, so yes, and like see, one thing that I saw in this question, if you read the question once, it says a non-negative real number is written in such a way. Okay, a non-negative real number. Now a non-negative real number in terms of English, I don't like understand whether it means a unique number or it means different numbers. So I guess it means different numbers, because either like if it was a unique number they would have mentioned a non-negative real number is written in such a way in all the places or something like that. Okay, so I guess they can be arbitrary, so that's really good. Like these 2024 places will be filled up with such values such that they sum up to 0.5. Okay, that's the clinical meaning of this. Okay, so now if we move again downwards, like see, after this how to fill, column 1 is already filled up with 0.5 to 0.5, so we can't fill anything here, so we go to column 2 now and fill this one with 0.5 in R3 and R4. Yet again, now if you see carefully, C2 is summing up to 1, but for R3 and R4, second place occupied with 0.5, but first place and third to 202 fifth place. Like listen carefully, first place and third to 202 fifth place are all empty. So they have to be filled with values once again such that they sum up to 0.5. Okay. So I guess now it's clear to you. So this will like go on like this, and now see carefully again. I am dividing this into two equal halves. Okay, there's a reason I am telling. Now see, as you keep coming down like this, shifting two diagonal, like not two diagonal places, this is like, if you have played chess, I guess the horses, not the horse, I'm sorry. The knight's move in chess is something like this. I hope. Okay, no. It is actually from here to here. Anyways, almost same. Okay, like the knight's move. Like this is a there's a very famous problem that you guys can't do right now. It's in higher mathematics. Like if you do in your future BSc or MSc maybe, then there is a good problem on chess using advanced concepts. You just don't need to know that there actually we study like what these pieces in chess can do. Okay, like people who play chess, they have to know a great deal about whole lot of this. Okay, don't think Magnus Carlsen wins. Magnus Carlsen, then all the other people, I can't get the names right now, all the other people who are winning these medals, trophies in chess, don't think they do it so easily. They have to do a whole lot of mathematics. Okay, they will not tell you, but they have to. Anyways, guys, so 0.5 goes on till like this, and now what will happen is when you strike the bottom, this line, you will strike the bottom somewhere, right? So what will happen is you will have some sort of this thing. If you divide by 2, it's actually 2, it will come on and end like this. Okay, because it's going diagonally. So when this ends actually like this, okay, wait. Okay, I did a mistake. It's actually not ending here. Okay, I'm sorry. 0.5s, it's actually odd number 2025. So if you divide that with 2, you will get a remainder of 1. So actually, I guess there will be a 1 space left over here. So 0.5 above. Okay, I hope this will end like this if we take our series. And now where this will actually end, this will end till 1012 places. And if you ask why, the answer is because 2025 is equal to 1012 into 2 plus 1. Okay. Like you would be wondering why am I teaching you simple tests of divisibility and remainder stuff right now, but believe me, these things, if you want to really go to advanced level of combinatorics, you have to jump on to your basics, because like these Olympiads, they contain problems on such topics which, like, you are like, I guess you will be fully determined that I will score 100% if those questions from those topics they come in my JEE, but that's for mains. Advanced is a different deal. Okay, we are preferring for the toughest. So anyways, that means there are 1012 places here. And now question is, what will we do with this part? Because this thing is over. So basically this part will be filled like this. Now see my line drawing, okay, very carefully. So this line, actually the space which is left below this box thing, this is actually a 1 unit space, okay, and this complete space will be filled with 1 by 2024. Now listen, why are we filling this with 1 by 2024? Okay, so there can be actually two cases here. Either you fill exactly 1 by 2024 in all the places, or something better than that, because we are not still sure if the values to be filled are equal or not. And we took the reasoning here also because we said that different values will sum up to 0.5. So better to say that we have to fill up values in each row and column such that they sum up to 1 by 2024. Okay. Like after that, because the reason is, if we take 1012 here, this is 1012, so this will also be 1012, right? Like wait, this complete thing here, from here to here, this is actually 1013, but this place, leaving this 1 unit space, this space has a length of 1012. So this particular space, actually, if we fill 1 by 2024, then if you sum up, the criteria of the rows and columns having a same sum will be actually fulfilled. Okay. Like, see, this is not going to help us in either way in our answer. Answer will be bit different, but I'm trying to take cases so that you understand what is going on. Okay. And now also, like, we can't leave that. This one space is left and we have to obviously fill something in that. So because nothing has been filled here, nothing has been filled here, and in none of these spaces, 1012 spaces, and obviously not here, so we can just put a 1. Okay, just put a 1 and last column, first column, like last column and last row, their sum is also 1 now. So this is when we come down to 0.5. Okay, so I hope you understood. Guys, I showed you two cases. And if you want a third case, then maybe you could take 1 by 5. I will show you that also. Wait. Okay, so here's another case. This case is when this was for 0.5 or half, and this case is when we put 1 by 5. Okay, so this is how it looks like. 1 by 5 occupies the element places. Here you will have 405 places, like 405 elements in the rows, and here you will have 1620 places in the rows. So to fulfill our condition, actually here you have to add 1 by 2025. Okay, like here we added 1 by 2024, or rather placed 1 by 2024. Here it will be 1 by 2025, and rest of it, the explanation almost we explained whatever we explained here, that remains actually completely same. We just change the alter the values. Okay. Okay, so guys, if you actually calculate R by C here, you will get it to be approximately 2. I am telling approximately 2 because we are not sure whether we have to add these, like whether the values being filled here are same or different. So I say approximately. Similarly, this also will have some R by C value. But as like you can see, right, as we take this half, 1 by 5, and as we try to decrease the value, our R by C value is keeping on increasing. Like as we try to decrease that non-negative real numbers value in each cell, our R by C's value is continuously increasing. So if we want to somehow figure out to which maximum extent this can reach and at which place, okay, we won't have to figure that out. So let's do that. Okay, so before proceeding further, I want to write down a few statements because otherwise, like this sum is a bit difficult. So if you have things off track, then maybe you would have problem taking this. Okay, so in column number say J, any column number J, suppose there are NJ red cells. Okay, I hope you remember what red cells are. Red cells are these cells which contain the maximum values. Suppose in column number J they have NJ red cells. Okay, and let their values, like the values of these NJ in each, sum up to SJ. Okay, like see, don't confuse between SJ and capital C. Capital C refers to maximum value, SJ refers to the sum. Okay, it is, don't confuse. So if we actually see average red cell value, if we try to find out the average of all the red cell values, or rather the average of all the maximum values in any column, then it will be Sj by Nj. I hope I don't have to tell you how to find an average. So Sj by Nj will be the average. Okay, so guys, after this, like, listen to one thing carefully. You can realize this, I hope. Okay, like see, general property of an average, like average is somewhat another name for mean. Okay, arithmetic mean in some cases, not arithmetic mean, I should say. It's a like diverse arithmetic mean or arithmetic mean over n numbers. An average, it is almost same. So you guys also know that there can be cases where arithmetic mean becomes equal to one of the elements, okay, whose mean we are finding out. That can happen, but in other cases it will always be less than the individual elements. Okay, so guys, like I can put, if I want to frame an inequality, I can actually say Sj by Nj will be less than equal to Cj. Okay, this is from like normal mathematical conclusion, nothing related to this. So I hope you have understood. Now guys, we'll just proceed a bit further, and now like keep on writing. This might be a little boring, but keep on writing. Okay, so for column number J, your, I'm trying to write fast, maximum is equals to Cj. Now each red cell in column n, okay, n is an arbitrary column, it will always be less than equal to Cj. Now listen carefully. Okay, not column n, I'm sorry. Each red cell in column is less than equal to Cj. So that average, like I hope I wrote a continuation of this only. Sorry, let's proceed. Okay, so if a column has no red cells, or guys, if you can wait for a few seconds, I will just write this down and then again start off this video. Wait. Okay, so if a column has no red cells, it still sums up to 1 across n entries. So maximum in any column, it has to be at least 1 by n. I hope this was clear. Okay, so basically our target is to find this n. What is this n? Okay, so now returning to our old boxing, like see, one guess that I got when I was solving this sum, I got a rough guess that 2025, if you observe, 2025 is actually a perfect square. and the square of 45. So I guess 45 will be our n here, I think, because if 1 by 5, like half 1 by 5, whenever we are sure, like increasing the denominator of the fraction, this thing like decreasing the value of the fraction, this r by c value is continuously increasing. So I guess lowest that can be is 1 by 45. If you go beyond that, actually what will happen is the max to max, see, 0.5 the case where half actually arised, half or 0.5 where it actually arised. The second case we did, it was a special case because there in the bottom one line and in the right hand side corner one line. Okay, so basically the last column and the last row, they were empty, but we still had an advantage. We just kept we just filled one in the last rightmost, okay, like in the cell which was the intersection of last row and last column, there we filled one, and because of that our conditions were satisfied. But that will not suffice everywhere. Okay, if you go beyond 45, actually what will happen is you will have 2 or 3 spaces, and after that, like, you would be so much, like, your arrangements would be so disoriented that you would have no provision to fill up any other value in order to satisfy your condition. So maximum value of this denominator n up till which we can actually consider this thing is, I guess, 45. Okay, I don't know about the intermediate values, but half was actually a special case because one last row and one last column were empty. Okay. Okay, so guys, I guess 45 will be, and don't worry, like, you might think that I am speaking out of the blue, but I will at last prove this also, that 45 is the one. Okay, so guys, what I will do is I will now draw the graph, I mean not the graph, the grid for the case of 45. Okay, so guys, this is our grid for 1 by 45. And as you can see, this 1 by 45 will actually reach the last row, and so everything will be completely filled, no like hustle of any ones or anything. And 45 will be the length of this part, and this part will be length 44 into 45. I hope you can understand why. And these, like, explanation remains same, values change. This complete place would add up to 1 by 45, all these places here, 2024 places leaving the first one. Similarly for this, the first and the third 2025th place will add up to 1 by 45, and here the filling will be done with 1 by 2025. Okay, like, see, these conditions are all because we have to satisfy what is given in our question, right? So on aid to that, I have made the conditions. Like, if you have any doubts, you can easily put and check away right now, then you will understand that it is all coming to be equal. Okay, like, our conditions are being maintained. Okay, so guys, I guess this will be for 45, but we need to prove that 45 will be our value. Like, my rough guess, because root 2025 is, I hope, 45, so I don't think any maximum value will suffice, but we need to prove that. That's the first thing. Okay, so let's do that, guys, quickly. Okay, so to prove this, I have drawn a grid here, and you can see these are the red circles which signify the maximum values. Okay, now these are sort of arbitrary because we are not sure where the maximum value will arise, and the orders that we showed here, they will be, might be the same. Okay, I will not say will be, I will say might be the same as these, or like it will depend on the value you are taking. So let's take this to be n1, n2 up till nk, say. Okay. And let's take this sum to be p1, p2 up till pk. I guess, I hope I wrote sk at the top. Okay. If I wrote sk, just use pk. Okay. Okay. In place of that, because I took p. So guys, one thing that we can tell is r is equal to, like, this was given only, s1 plus s2 up till sk. Okay, capital R, and your C, capital C, will be greater than or equal to S1 by N1. Now, where did this S1 by N1 come from? So I would remind you something, and here is what I have to remind. This is your Cj, and sigma Cj was equal to capital C. I hope you remember this from the question. Okay, that's why actually I wrote this statement here, because I knew it would be of use later on. Okay. Okay, so S1 by N1 plus, okay, wait, I have written P1, right? Okay, do one thing. Just replace S1, S2 with SK. Yeah, that's better. So S1 by N1 plus S2 by N2, and this will go up till SK by NK, right? But that's done. But what about these values? Because rows are covered, but this is not. So in order to cover that, actually, what you will do is this. Like, see, 2025. Okay, so 2025, out of which 202, like from 2025, the number of spaces occupied are k. So 2025 minus k are the number of spaces remaining. And for that, this is your, you can say, S remaining. And the denominator will be n remaining. N remaining will actually be nothing but 2025. Or wait, don't signify this as n remaining. Just listen. 2025 minus k, because there are k spaces occupied, and 2025 minus k left, and 2025 because the total places were actually 2025. Okay, don't confuse in this part. This is actually not n remaining. I'm sorry, this is not n remaining. This is just 2025, the total. Okay, like, see, this is happening because here 2025 minus k places are left. Okay. Okay, so guys, C is for the columns, R is for the rows, and some more things. Like, one thing is S1, S2, SK. Okay, each of these things, they will be greater than equal to obviously your SI by NI, the average, sigma SI by NI, obviously, but they will be also greater than equal to something else, and that is 1 by 2025. Now you will ask me why. Because if you see the case for 1 by 5 and 1 by 45, half, the 0.5 case was an exception case, because there we had one last row and one last column still remaining. So there we had to take 1 by 2024 for that big box and fill one in the, like, extreme rightmost downward corner. Okay, but after that you will see 1 by 2025 is repeating almost everywhere. I don't know if there is any exception case in between or not. I don't think there will be, because in a few minutes you will see that there won't be any, because this would be proven to be correct. And like, in that case, I guess this will be greater than equal to 1 by 2025 only. Okay, and that is the reason, actually, like, we don't know what the intermediate values, if there would be any exceptions like 1/2 or 0.5 or not. So for that, actually, I put greater than or equal to. Equal to, very good. If not, then it will be greater than. Like for 1 by 2024, that came in case of half, 1 by 2024 is greater than 1 by 2025. Okay. Okay, so like, this thing you would actually need, so I have written it. Okay, so guys, now we have to do a little bit of, like, mathematics. Like, this is all mathematics, but now we will get into some algebra. So for that, actually, I will use another result, that is 2025 is equal to n1 plus n2 plus dot 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 till nk. Like, I hope you can understand this. All the numbers would sum up to 2025. So actually, if we write this expression C greater than equal to, this would actually become, like, first see this and then you will understand. N1 by 2025 plus S1 by N1 plus of Nk by 2025 plus Sk by Nk minus K by 2025. Now, how did all this come? So this came basically because I split this particular thing as 1 minus K by 2025. You can see your K by 2025 here, and for that 1 I wrote it as 2025 into 1 by 2025. 2025 in, like, here you would have a 1, and I wrote this 1 as 2025 into 1 by 2025. And after that, 2025, like, sorry, 1 by 2025, it remains, and in place of 2025 I write this. n1 plus n2 up till nk, and then I open up the bracket. So that's what you are getting. Okay, I hope no confusions. Okay, so guys, after this step, actually what we will be doing is we will be going backtrack. Okay, like I will be doing things a little bit reverse way, because as we go reverse, we will actually find out our solution. Okay, let's just see what I'm doing. Okay, so guys, after this thing, actually we have n1 by 2025 up till nk by 2025 right away. So what I can do is I can write sigma of ni by 2025 plus of si by ni, this thing to be greater than or equal to your sigma 2 root si by 2025. Okay, now see, I have jumped one step here actually. This is nothing but am greater than equal to gm. Okay, so just forget this sigma, just think that the sigma is not there for a while. You have this thing, you take this thing and apply am greater than equal to gm, so you get this thing. Okay, and after that, like 2 root si by 2025, you get this from here with am greater than equal to gm. And after doing am greater than equal to gm, we actually sum up both sides. Okay, so if we sum up both sides, actually this thing would come out to be equal to greater than or equal to 2 by 45, because root 2025 is 45. So 2 by 45 times of root s1 dot 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 till root sk minus of k by 2025. Okay, so like I hope this part was clear. Like see, okay, wait, I have to maybe write this a bit clearly because you might be having confusion about what happened right now. So see, n1 till nk and s1 till nsk, this part put in a bracket. We took this part, did greater than equal to and by am and gm, and then found this value, and then we took this value and punched it into this particular expression c greater than equals to. So this is what we have right now. Okay, so after this, actually what we will get is greater than or equal to 2 by 45 times of your root si minus and k by 2025. This thing actually you can write. Okay, so guys, I just wrote something bit wrong here. So one thing that we are going to do right now, just listen. Okay, I am calculating r by c. Listen carefully. I am calculating the value of r by c for that 1 by 45 case. Okay, so if we calculate, this will be 45 divided by columns, and columns were divided into 45 and 44 into 45, two length places. Okay, two lengthed places. So 45 and 44 into 45, which means this will actually be 1 plus 44 by 45. I hope you understood this. Row by column. Okay. Row by column we are calculating, and where r is the maximum value, the sum of, sorry, not maximum, r is the sum of all those maximum values, and c is the sum of the maximum values in column, the first in row r and then in column c. Okay. So for r actually it goes to 45, and for columns it goes to 1 plus 44 by 45. Okay, so why I did 1 plus 44 by 45? So 45 reasoning I hope you can easily understand for the rows, but 1 plus 44 by 45, why did I do this? Okay, so basically listen, because 44 by 45 here, if you see columns, the columns we have taken here, there are 44 into 45 columns here. Now 44 columns will come from here. Okay, if you count from here 1 2 3, that will go on till 44 columns. Okay, wait. Okay, so guys, just erase this. I'm really sorry, I spoke something which is not correct. Okay, listen, basically r by c. Okay, this comes out to be, because 45 by 1 plus 44 by 45, this comes out because if you observe, just observe my pen, here we have 2025 entries of 1 by 45 in the rows. Okay, 2025 entries of 1 by 45, which means 2025 into 1 by 45. which is 45, because square root of 2025 is itself 45. Okay, like you would ask me, then what happened about the values we are putting here? You are putting 1 by 2025 exactly. Okay, in all these places. If I said before that here there will be arbitrary conditions, then just ignore that. Actually here 1 by 2025 will go into all the places equally. Okay, I just calculated that, and it is the only condition where this thing is validating. Otherwise the validation will become wrong of the statements in the question. Okay, so 2025 times of 1 by 45 gives us 45. So that is why in the row it is 45. And for the columns, it is 45 times of 1 by 45 entries in first 45 columns. So 45 times 1 by 45 is 1. And after that, you will have 44 into 45 entries. Listen carefully. It is 44 into 45. I will write this better. 44 into 45 copies of 1 by 2025, because as I said, in each place here you will put 1 by 2025 irrespective of whether it is a row or a column. So actually it comes out to be 44 by 45. Okay, I hope now it's crystal clear. So I will return to our question. Okay, so guys, if you calculate this thing actually out, you will come out to be receiving 2025 by 89. Okay, and actually this is our answer. This is our answer. Okay, now you will ask me why, because 45 after 45, actually if you go on any beyond values, you will not find any concurrency. You will not find any validation for the statements provided. Actually 2025 by 89 is your answer. Okay, like I don't know what they might have done in the original competition, but I guess this is the way they might have tested values. But like, see, in JEE you don't do this stuff, but in Olympiads things are much broader. Okay, it's a pure mathematics place. It's not like physics, chemistry, and anything else. It's a pure mathematics place. So I guess what they might have done is they would have calculated like till 45, and after that from 46, 47 they must have seen that the conditions are not sufficing. So in that case they must have taken this 2025 by 89 and then proved that this thing is actually valid. Okay, so I am walking on the same track. Anyways guys, I hope this part was clear. So actually what we need to prove is C is greater than or equal to 89 by 2025 times R. This is what we need to prove. So I am using this thing and backtracking now. Okay, so if we go a little backtrack, actually using this value as a reference value, you can easily say one thing. Okay, just see C greater than equal to this part, because C greater than equal to is 89 by 2025 R. So if we can use this part of the inequality to equal with this, right? So actually 2 by root 45 times root S1 plus dot 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 till root SK minus of your K by 2025. This thing can be greater than or equal to 89 by 2025 times R. Okay, but actually it is not. Why? Because it will not be. I wrote this intentionally because some people make this mistake. Don't make. Basically, after you sum this thing up, okay, 2 by 45 root SI, just put a sigma here, and this will actually become minus 1 by 2025. Okay. Okay, so actually this won't be the sigma, just see. Okay, like even this sum is so difficult, I am even having seizures while solving this sort of. Anyways, so guys, this will actually be greater than or equal to 18 by 2025, because this is, we are using this as a reference. So 18 by 2025 times not capital R right now, till now it will be SI. And actually when we put a sigma, this thing becomes this. And after that maybe we can say this is greater than equal to after this. Okay, not before, because when we do this sigma manipulation you will see this is the expression that we arrive to. I am backtracking, remember. So this actually came from this expression. So our final expression for this thing will be 2 by 45 root SI minus 1 by 2025 is greater than or equal to 18 by 2025. times of your SI. Okay. Okay. So actually we need to prove this thing to be correct right now. Like everything else is done. So one very efficient way is multiply this with 2025 right now, both sides of the equation. So 45 2s are 90 root SI minus 1 greater than or equal to 89 SI. So what you have in hand is a quadratic equation finally. Like from a permutations question, we arrived to a quadratic, which was nowhere to be seen. Okay. This is like you guys are telling me bring good permutations questions. So this is the level that you might imagine if you want good questions. Okay. And you should do because you are a JEE Advanced aspirant, remember. So 89 SI minus 90 root SI plus 1. Like this thing is, I will write it in a fresh way. This is less than or equal to 0. So we can factorize this easily, I hope. 89 root SI minus 1 times of your root SI minus 1 is less than equal to 0. So finally this inequality comes out to be 1 by 89 is less than equal to root SI less than equal to 1. So if we prove this thing to be correct, then our sum is completely done. Because if this is correct, then this will be correct, then this will be correct, and then like backtracking going forward, this thing will be correct. Okay, like really intelligent way to do the sum maybe. Okay, so 1 by 89 less than equal to root SI less than equal to 1. Is this correct or not? So guys, first thing is that I told you something in the beginning that SI is greater than equal to 1 by 2025. Now this thing is greater than equal to 1 by 2025. And if I take out from here like square both sides, SI is coming to be greater than equal to 1 by 89 into 89. And this thing is 1 by 45 into 45. So I hope SI is greater than equal to if this, then it will obviously be greater than equal to this. And obviously SI less than equal to 1 is very, very valid because above 1 we can't go, right? That's our maximum permissible case. The first case that we considered, that one element in each column row intersection will be 1 and all the others will be 0. And then we will proceed successively diagonally downwards. Diagonally downwards. Okay, it's like the leading diagonal of a matrix, sort of. So I guess our condition is correct and so our sum is done. Therefore, R by C comes out to be equal to 2025 by 89. This is the final answer. And guys, if in any case they would have given us, maybe not given us any value, 2025 or something like that, if they could have asked us also the general value of this, then for the general value, I have also calculated in terms of a variable. It will be m square by 2m minus 1. You can put the value and calculate, it will come to be exactly same. Okay, so this is the general answer for this question. If they had not given us, like if we didn't have, like say in place of 2025 they would have given us m square. Okay, then all the calculations would have been done on this. Like everything would have been exactly same. Only thing is you would have a variable instead of a number. Okay. Okay, so guys, I hope this is the end for today's video, and this was the first time I brought in an IMO question. So if you have liked the video, do like, share and subscribe because I spent a whole lot of 3 days to solve this question and it has been really tiring for me because I have been journeying a lot ever since. So in between it has been a little very tiring for me to solve this, but I did. So please do like, share and subscribe. And guys, you would have doubts on this, so don't panic. Feel free to ask in the comment section. And I would bring in the other PYQs also. Like there are a lot of PYQs on IMO. We don't need all of them. Like this is a bit JEE relevant, so I thought to bring, but we don't need all of them. I will try to select, or maybe if not, then I would bring all of them. Okay. Anyways, guys, this is the end for today's video, and thanks for watching.